This video on Hopper, on the 6502, is to discuss what I've been calling Tiny Hopper. So Tiny Hopper is a version of Hopper that compiles to less than 8K of machine code for the 6502. Regular Hopper is about 20K of machine code on the 6502. But Tiny Hopper is about 500 bytes shy of 8K, so it fits into an 8K ROM. I'll just demonstrate it quickly, and then I'll discuss what it really is. So let's bring up a picture of the machine here and compile this program. Load it into the debugger. This is the debugger. And let's just F5 it to run it. And then, as expected, you get your little blinky light going on there. And it's the full debugging experience. I can Control C, I can step through the debugger. You can see the slight delay every time I press delay. I can traverse the file as I'm going. Yeah. So it's regular Hopper experience, a full debugging experience at a source level of a high-level language on a 6502 machine. If I press F5, the light should start flashing again. And Control C, I'll break it. You get the idea. So now let me explain what it is. So one of the big parts of Hopper, so Tiny Hopper, the ifdef, is what makes it compile it for the smaller version of Hopper. The big thing that we leave out to get a super stripped down version of Hopper is we leave out the heap manager. So automatic memory management and garbage collection, heap garbage collection. So that means you lose out on your reference types. So the big one that you're going to miss is strings usually. Well, not if you're just doing blinky light stuff and doing what people do on microcontrollers, like with GPIO pins and things. You're not going to need strings. But as soon as you start trying to do anything that has any human interaction, you're probably going to need strings. And strings are a reference type that's automatically managed by the heap manager and the garbage collector. The other reference type you're going to miss are the other collections, which is arrays, lists, and dictionaries. Pairs are just used by dictionaries, so key value pairs. And then in Hopper, both float and long are also reference types because a stack slot on a Hopper is 16 bits wide, and longs are 32 bits wide, and floats are also 32 bits wide. So they're actually managed on the heap, the same way you would a string. So when you build Tiny Hopper, you also lose longs. But you've got everything else. So you've got uints, ints, bytes, booleans, chars. You can do your own direct memory access using memory, so it's got full access to the entire memory of the 6502. So I've used this to do things like simulate arrays, for example, just build my own arrays. It's got some useful features like read bit and write bit, which are useful if you've got a bitwise array. So the start address of where your array starts and then the index in it to read and write a bit. So it's not completely worthless in terms of memory access. So you could build up your own sort of poor man's version of strings using direct memory access and managing memory yourself. Let's have a look at this here. Yeah. So there's allocate and free, which exist, just not heap management. So it's funny to talk that way. You can access the memory directly and you can do allocate and free, but you can't do release. So the heap manager does reference counting and garbage collection. So that's what's missing. Um, all the other peripherals still work. Time, the serial port, because the serial port is character-based. Some of the screen stuff works, some of it doesn't. So the character-based stuff does, the string-based stuff doesn't. Yeah. Anyway, it is a very small footprint for a high-level language with a full debugging capability. And that's about all I'm going to say about Tiny Hopper for now. Thank you for watching.